So far, we learned that the fundamental counting principle says if you have multiple events, the first event can be done in m ways, the second event can be done in n ways, and you have a third event that can be done in k ways. And the third event can be done in k ways. Then the events can be done in m times n times k ways. We can just generalize this principle to have as many events as you want. So how do we apply this principle? Take a look at this example. The example says the access code for a car security system consists of 3 digits. Each digit can be any number between 0 and 9 inclusive. It means that you can include 0 and 9 as well. First part, how many access codes are possible if no digit can be repeated? What's the meaning of this? Part A. It means that, hey, you can select 0, 1, 2. You can have 0, 1, 3. Then 0, 1, 4. 0, 1, 5. 0, 1, 6. 0, 1, 7. 0, 1, 8. 0, 1, 9. Right? Well, what if my first digit is 0 and my second digit is 2? 0, 2, 1. 0, 2, 3. Guys, I'm not using 0, 2, 2 because it says it's not allowed to repeat the number. 0, 2, 4. 0, 2, 5. 0, 2, 6. But how many I should list? I'm not going to list them all. I'm going to use the fundamental counting principle to do the job for me. I don't have time to list these all. I know it has 3 digits. The first digit, the second digit, and the third digit. How many ways I can select the first digit? The first digit can be 0, can be 1, can be 2, can be 3, can be 4, 5, 6, 7, 8, and 9. 10 different ways I can select the first digit. What about the second digit? How many options do I have for the second digit? Note that the repetition is not allowed. So for the second digit, I have 9 options, not 10 options, because one of the numbers are already selected, like this case that you see. If you select 0, you are not allowed to repeat 0 again. You have the option to select 1, 2, 3, 4, and so on. So you have 9 options for the second digit. This is your first digit, and this is your second digit. What about the last digit? How many options do I have? Well, I know 2 numbers are already selected. For example, I selected 0, I selected 1. I am not allowed to select 0 and 1. I have 8 options for the last digit. This is my third digit. So how many ways in total? How many options do I have? The fundamental counting principle says you need to multiply all of these numbers together. You have 10 times 9 times 8, 720 ways to set a 3-digit access code with no repetition. What about part B? Part B says, hey, you are allowed to repeat some of these digits. Why not? For example, part B, I can have 0, 0, 0. I can also have 1, 1, 1. I can also have 2, 2, 2, and so on. But again, I'm not going to repeat these. I'm not going to write these down. I'm going to use this theorem, this principle that I just learned, to help me count the number of possible access codes for me. So here I have the first digit. For the first digit, I have 10 options. What about the second digit? I can repeat these numbers. So I have the same ways, I have the same options, 10. What about the third digit? For the third digit, I also have 10 options. The fundamental counting principles say, okay, now that you have these numbers, multiply them together. 10 multiplied by 10 multiplied by 10, 1,000 ways to write 3-digit access code for the car security system.